In this lesson, what we're going to look at is how we can separate mixtures into their different components. And there's going to be a few different techniques we have for separating mixtures depending on what that mixture is made up of. So this is the experience and outcome related to that. Differentiate between pure substances and mixtures, and select appropriate methods for separating mixtures into their components. So let's see, can you remember when we had a compound? How was it able to be separated into its elements? So take a moment to think. If you want to write down your answer, pause the video and you can write things down. But how could you separate a compound into its elements? Well, the key to doing that was electrolysis. You needed to use electricity and a lot of energy because you were needing to break the chemical bonds between the atoms in a compound. So it required a lot of energy because you were breaking chemical bonds. Mixtures are not chemically joined. So it's actually a lot easier and you need a lot less energy to separate mixtures than electrolysis for separating compounds into elements. The types of process that separate mixtures are called physical processes. And mixtures get separated based on their different properties. So this diagram is a representation of a mixture where the things have been separated based on one of the properties that they have. They've been separated based on colour. And the method that you could use to separate those sweets into the different piles is you could just use your hands and physically pick them apart and separate them. And what you have chosen is to separate them based on colour. So colour would be one of the properties of those sweets. Now there are three types of mixture that we would like you to know how to separate. The first one is how to separate an insoluble solid from a liquid. The second one is how to separate a solute, so the thing that's dissolved in a solution, how to get it back out of a solution. And finally, how to separate a solvent from a solution. So if you have a solution of a solute dissolved in a liquid, how do we get that pure liquid out of the solution? So there's three different types and each one has a slightly different method. So the first one is how do we get an insoluble solid separated from a liquid? Now the process for doing this is called filtration. So if a substance does not dissolve in a solvent, it is insoluble. So an example of this would be sand and water. Sand does not dissolve. And the process we use to separate it is filtration. And filtration works a little bit like using a sieve in HFT. So using a sieve to separate things of different size. So when you have a mixture of sand and water, when you set up a filtration, what happens is that in a filter funnel, which has filter paper inside it, and there's a diagram on the next slide, the sand stays behind in the paper, and we would describe the sand as the residue, whereas the water, the liquid, passes through the filter paper and is called the filtrate. So this is a diagram. We have our solid and liquid together in that beaker on the left-hand side, and then we have a funnel set up with some filter paper inside it. So the filter paper forms a line and the filter funnel is usually made of glass or plastic. If we pour that mixture of solid and liquid into that filter paper, what happens is that the liquid is able to pass through the filter paper and down the filter funnel, whereas the solid cannot get through the filter paper and gets left behind. The solid that gets left behind, as I said before, gets called the residue, and the liquid that passes through gets called the filtrate. So filtration is how we separate an insoluble solid from a solution or from a liquid. Now the second separation that you need to be aware of is if we have a solution, how do we get the solute back? Now the process we do this is evaporation. Now remember, the solute is the solid that was put into the solution. Evaporation is a process that turns a liquid into a gas. And it doesn't require you having to boil the solution, it just takes a bit longer than boiling. So evaporation turns the liquid into a gas and the solid gets left behind in the beaker. So for example, in the experiment you might have been able to do in class where you dissolve the blue powder in the water, if you wanted to get that blue powder back out again, you heat up a solution slowly over time, and what happens is that the water evaporates off like a puddle evaporating in the street, and what gets left behind would be the blue powder. So evaporation is the process. So the way to speed evaporation up is to heat it. So the bit of equipment used is an evaporating basin. Now it is a bowl-shaped container that is made of a material that allows it to be heated up very, very hot without melting or breaking. The solution gets put inside the evaporating basin and it gets heated over a Bunsen burner, usually a Bunsen burner on a roaring or a blue flame to make it very hot. Now, as the water starts to evaporate and maybe boil, the level of liquid drops and the solution can no longer hold all of the solute inside it, becomes saturated, and over time, as more and more water evaporates off, the solid gets completely left behind and all of the water or liquid solvent has turned into a gas. The final way of separating mixtures is if in that situation where you had a solution, what if you didn't want the solid but you wanted the liquid that was part of a solution? Well, the way of separating the liquid is called simple distillation. Now what we do is a very similar procedure to the evaporation. We heat up the solution. And as we heat it up, the solvent evaporates and turns into a gas. And that starts to separate the solvent from the solute. So because the solute remains behind, the water or the liquid evaporates. If we want to obtain that liquid back again, what we need to do is cool that gas as it evaporates down. And we have a piece of equipment called a condenser that allows that to happen. And that piece of equipment is shown on the next slide. So here we have our solution and we heat the solution up. Now this time, rather than being open to the air so that the liquid as it turns into a gas escapes, it's forced into this side tube here. Now this side tube is surrounded by cold water around the outside of it, and that cold water keeps it very cool. And as that water that's turned into water vapor enters into that side arm, it gets cooled down enough that it turns back into liquid. And as it turns back into liquid, it then runs down that side arm and gets collected in that beaker on the right hand side. So we've got cold water going in through this condenser, the water vapor, and you can see the water vapor condenses into liquid and it drips out. So we're able to recollect the liquid from the beaker on the left-hand side in the beaker on the right-hand side, and the water on the right-hand side doesn't contain any of the dissolved material inside it. And then once you've evaporated all of the things on the left-hand side, you'll be left with the solute in that container and all of the solvent on the right-hand side. So this set of slides went through the 3 techniques that you need to be aware of for separating mixtures. So the first one, filtration, is used if you have an insoluble compound or chemical that you want to remove from a liquid or solution. The second method, evaporation, is used if you have a solution and you just want the solute, the solid that was dissolved in the solution. And this final image that we've got here is a representation of simple distillation, which allows you to capture the solvent from a solution by heating it up, turning it into a gas, and cooling it back down into a liquid at a different location. So those were the 3 separating methods for separating mixtures, and I will see you next time.